Okay. Hello, everyone. I'm very happy to have Sujit Gujar here from Triple IT Hyderabad. He works in blockchains, game theory, and distributed AI. Before Triple IT Hyderabad, he was a postdoc at EPFL, researcher at Xerox, a PhD student at ISC, an undergrad at GEC Pune, and a high schooler at Maharashtra Mandal Marathi Shiksha. Born in. That's what So yeah, let's welcome.
Thank you for introduction and thank you for inviting me here for a talk. So today I will talk about our recent work. So this MEV is Maximal Extractable Value is a term related with blockchains. And so I will introduce you what is MEV, what is this technology proposer, builder, and order flow providers. And what are the concerns in current execution and why we need to redesign some of the incentive schemes there. So this talk is divided into two parts. So first part I will talk about where we are using game theoretic approach, Shapley Value based approach, how MEV should be shared across all the entities involved, primarily with the builders, proposers, and OFPs. And in second part I will talk about how we should share, even we should share MEV which is extracted in blockchains with the transaction creators, because they are the one because of which this MEV is generated. So blockchains and cryptocurrency market has been rising with like 17.3% CAGR rate. It's more than 5.43 billion US dollars. And it has really given new ideas in distributed system for distributed consensus. So it started with Bitcoin, which introduced proof of work consensus. So traditional consensus algorithms like Paxos and all those things. Security guarantees were like 2 by 3, whereas proof of work showed that we can achieve consensus with 51% honest nodes. But in proof of work, the idea is if you want to write to the system, you have to solve some cryptographic puzzles. And the first person who solves this will write the block. The data is written in terms of blocks. That's why it's called blockchains. So it's good, a very good security guarantee, but it involves solving a lot of crypto puzzles, which doesn't have otherwise any practical use, and it consumes a lot of electricity. So scientists were wondering, can we develop another scheme? And it gave rise to proof of stake, which are more energy efficient and faster. So here, you will get a chance to write to the system. The chance is proportional to your investment into the system. It's called proof of stake. You have own 20% of those coins or that currency, then chance that you will be the next person to write to the system will be 20%. And Ethereum shifted to merge. They call it merge. Ethereum was using proof of work, but they shifted to POS 2.5 years back. So in proof of stake, one interesting fact is, at the end of this round is known who is going to write next block. So instead of calling it a miner in Bitcoin, it used to call mining. They call it proposer because he's going to propose the next block.
Yes. By energy efficient, you just mean it doesn't consume as much energy as proof of work.
Yes.
It's not that it's not an energy efficient problem. There are still computation problems being solved there, or nothing of that.
Not that is exponentially less computing.
Okay.
You have to just do some hashing, and based on the hash values, you have to decide who will be writing the next block.
Okay.
Whereas crypto puzzle in Bitcoin, you have to keep solving hash puzzles almost every second. There are 2 to the power 20 hashes per second are happening in Bitcoin. Here it's very negligible.
What do you mean, write the next block?
So in blockchain, data is written in terms of blocks. All the transactions, so roughly 2,000 transactions are in the one block. And who will write the next block? So
it depends on who's doing the transactions.
Transaction state does not write the block. They are the miners who are maintaining this network.
Okay.
They write the block. They are keeping all the transaction data.
So just to make sure that I understand, so there are these miners who will basically say that, okay, here is what the ledger looks like, and I attest to this ledger.
Yes.
That's what.
Yeah, everybody's
that's what I
attesting,
do.
yes.
And every time you do that, I mean, like you get a small amount of this thing. In the proof of work sort of thing, you might be spending time in order to solve these challenges, but you might still not end up writing a block at all.
Yes,
But here, proof of stake, I mean, you know whether or not
you are writing or not.
okay.
Yeah.
Okay. It's just that the wasted work doesn't happen in the
In
proof of stake.
yes.
Okay.
So that is the way blockchain will move. Most of them are shifting to proof of stake. The proof of work, in proof of work, the miner is the one who is solving this crypto puzzle and maintaining this whole database of all transactions. Like our normal transactions, we don't keep the database. Database is with the banks. So these are the who are keeping all crypto. Bitcoin miners is the one who is keeping all record of Bitcoin transactions. And anybody can check it, but they are the ones who are maintaining it. And they are the one who are adding to the database.
And they are the ones solving this extensive.
Yes. That's clear? Okay. So why do they do this work? So there are two types of rewards designed in proof of work blockchain and which carry forward to proof of stake. One is transaction fees. So each transaction creator can offer transaction fee to the miner for adding his transaction to the database. Like whenever we use card, the merchant pays roughly 1% to the Visa network or MasterCard based on our network. So here it's optional. Traditional systems is mandatory. So there was time when this Visa and MasterCard or they were used to charge 2%. Back in 2000, some of you may know that if you want to go to shop, if you want to use credit card, they will charge 4% extra. These cryptographers were like, this system is for us, so we should decide how much should we pay as a transaction fee, not some centralized entity. So it's optional here. So you offer more transaction fee, chance that your transaction will be added quickly is higher. But it's optional. And also block reward, because this was designed for a currency, cryptographic currency. So our traditional currency, each country, the government controls how much currency should be there in circulation. The printing, minting the coins, printing the notes. Here, who will do it? Because it's completely decentralized. So if you write a block, you can generate new coins. You are eligible. That is called block reward. So in Bitcoin, it started with 50 coins per block, and every 4 years it keeps halving. So total at most it will be 21 million blocks. 21 million Bitcoins will be generated. But that is specific to Bitcoin. You can design any proof of work where this will not happen. So we have written another paper where we showed that because if we have to deal with other real world which is inflationary, well, this become non-inflationary currency. When you have only fixed number of coins around available, it's non-inflationary. But you are outside world being inflationary, this will not remain secure in long run. That's a different story. But there's a block reward, and these miners are doing all this work to grabbing block reward and transaction fees. So currently block reward is 3.125 or something like that number. And how these blocks are put is generally these miners, when they want to solve this puzzle, they have to collect these transactions. So what they have to typically do is they first grab the transaction which are paying higher transaction fees. And then they keep solving the puzzle. But are there ways in which they can generate more money? That's what some of the engineers realize.
This is in proof of work.
Proof of stake. No.
Proof of stake.
Yeah, now we are shifting to proof of stake. Sorry, I should not be added. So can miners earn more? And this is primarily happening in Ethereum. You can get some analogy with proof of work, but it is not going to be that evident. So first instance, engineers showed that there is a front running. What happens is somebody say you are a miner and you saw that there is some transaction which is purchasing say SBI shares a block deal. So you have information now the price is going to shoot up. So you buy a SBI stock, put that transaction in the blockchain first, and then add this transaction, which is a block deal. So the price will shoot up and you will make money. This is called front running. So you are earning now more or your expected transaction fees and block rewards. So they started calling it minor extractable values. But now it's no more called minor, it's called maximal extractable values. I will tell you why it's called maximal in a couple of slides. Because there's no more miner doing it. There are other attacks they found. Rather than attacks, it should be called like another way of generating more money. It's called back running, where you see some profitable transactions and you place a new transaction right after the user's transaction because he's selling something. So you buy something. So there are many ways whereby placing the transaction appropriately, you can make more money. Sometimes even sandwich. And what is happening in this cryptocurrency world is there are multiple exchanges available. So you observe that somebody is buying these coins on some exchange. So you buy at other exchange, which may be available at lower price and sell it to this guy in this exchange. You are a miner, then you can do these things. So sometimes you put your transaction in between two transactions. It's called sandwiching. So typically, some transactions which are like publicly known, from that, if you can generate more money, it's called arbitrage. So buy low in one market, sell in high in another market. And is this real? Yes. This is Ethereum MEV gross profit in terms of ethers. So the last year beginning, it was more than 500,000 ethers were generated out of this reordering transactions in a way or adding some transactions which will benefit you. And one ether is around $2,500. So this becomes $1.25 billion. So, and why this happened in US prominently?
So what is the notion of an ether?
So the Ethereum, they call their currency as ether.
I see.
Bitcoin is Bitcoin, Ethereum is called ether. Litecoin, so they're different. Ether is one currency. So when we shift to the blockchain, Ethereum shifted to proof of stake. Instead of calling it a miner, they started calling it a proposer. So now at the end of this round, we know who is going to write next block. And the proposer's goal being traditional, they have invested in such a way that they want to be a proposer. They want to increase their chance of proposer. If they have to extract such extra value, they have to invest additional resources. So considering block rewards and transaction fees, they may not be keen on be efficient at this extraction. So it has given rise to, in the Ethereum market, entities called builders. So what they do is, they specialize, they invest their hardware and software in which will be efficient at extracting these values from these transactions. They will write a block. If I know that you are going to write a block, next block, I will pay you. You write my block. So whatever the block reward transaction fees, I will grab. I will additionally reorder them in such a way that I can make more than that. And I will be willing to pay you. So you know that anyway you would have earn say $500,000 in this block. I am paying you $410,000. Why not? So nowadays, Ethereum, most of the times, proposers don't really write a block. Builders build a block and they sell it to proposers. So this is called proposer builder separation. And even now they conduct auction among builders to select such block. So then there are multiple builders available. So they conduct auction. And the one who has to build, the proposers write their block. And there are a few entities which are searchers. They work on smaller set of transactions and they just reorder smaller set of transactions. So, but the builder searcher, some researchers don't separate them because builder could be searcher. They can also do this job. But there are few entities who do this. So sometimes builder take transactions from searchers who have found smaller bundles, which will be profitable. Or builder can do themselves. And this transaction, generally nobody writes their own transaction. These are also transactions of small programs. So the end user will not be interested in writing programs. So there are wallet service providers who write transactions for you. You just say that I want to buy from this cryptocurrency, I want to buy this securities or I want to buy this currency. These wallet service providers will write these smart contracts for you. So they are the one who many times know this transaction first. So the searchers or builders actually buys these transactions from OFPs. It's called order flow providers. Technically, they are called order flow providers. So these builders or searchers buy these transactions from them. So all the market may look like this. So he's the one who is going to supposed to write the block. But these are the entities who will really construct blocks. They will look for smaller transactions or they can be act as a searcher. And these are the OFPs who really have access to transactions firsthand, which are at least with their whatever service they are providing, their users' transactions, they know it. So we are in this first part, we will assume integrated searcher builder because we don't distinguish between them. So we'll assume they are just builders and focus on proposer, builders, and OFPs. So how much I told you, like the $1.25 billion of extra money was generated by these builders in 1.5 years. But literally, all this work is done by builders, but are they gaining really much? Because they have to buy transactions, so they have to pay service providers, they have to pay proposers to write to their block. So what is happening is actually, this is just November 23 data. This is 712.30. So this is the largest builder. In 1 month, he made only this much profit in the end. So only 2 to 3% of this extra money generated is with the builders. The rest of the money goes to proposers and OFPs, especially OFPs. They make maximum out of it. So our concern was builders do all the work, but lose most of it in bidding to OFP and proposer. And all this is possible because of transaction creators. They are the one, their transactions are getting reordered and through which this extra money is generated. But there is no reward for them. So we started thinking, can we design marketplace algorithms where such surplus rewards are shared between all these entities fairly?
Given that it is a market already, why isn't it already fair?
It's just evolving, right? So we need better systems. It's just 1.5 years.
If builder is invested in somehow and it is not making enough money, will he exit the system?
That will eventually happen. That should not happen now. Otherwise, only few builders will be left. And if it is few builders, it will become centralized system. The whole idea in blockchain was it should be decentralized system. There should be, like if you see the previous slide, so these builders are almost not making nothing. So they will eventually drop out. And only few will be left. And then it will lead to centralized.
By the way, these builders are the same as
So once you move from proof of work to proof of stake, they are no longer called miners, but they are called
Proposers.
And proposers are builders or
They can be builders, but typically they are not builders. Builders, there is new entities have come up. Who are working?
this happens only in
Ethereum, it is happening.
Okay.
So these are the popular builders in Ethereum. They are building blocks and they are asking proposer to write their block.
Okay. But doesn't proof of stake by almost by default let people with larger stake take a more, it tends to be more centralized, no? Doesn't proof of stake by almost by, that's in fact, that's one of the criticisms against proof of stake.
It can lead to centralization. If I can start buying more and more ethers, then I will become.
You get
But same can happen in proof of work. If I buy a 51% computing power, like suppose you all are mining proof of work blockchain, maintaining whatever computing power you together have. If I add that much, then it will be centralized. So, but proof of stake eventually, if it's not designed properly, can lead to centralization. We had some workshop paper on that. We need because if initially who are the miners? If we 5 people started mining and only we sold few coins to others and now they are also miners. But if I have 90% stake, that means I will ride with 90% probability. Then there's a block rewards I will earn. So my stake will keep improving and the chance will keep improving. So initially, if the distribution is not correct, then centralization will happen in proof of stake. But if initial distribution is good, then typically it's not going to be a challenge. So in first part, we focused on builders, OFPs and proposers. That's where all the transaction, this MEV transactions are happening. So then I reiterate, I will not consider searches separately. So what we want to do in this is like every entity should get their fair reward, that is their marginal contribution to the system. So that's why we took a cooperative game approach. So cooperative game is also called characteristic from game. So typically cooperative game consists of set of players and characteristic function. Characteristic function mu of S represent how much agent in S, if they are alone working together in competition with rest of the agents, how much they can generate value. That is mu of S. And in cooperative game theory, Shapley value is one of the most prominent solution concept used. Like if we know characteristic of function, how this total surplus.
I didn't understand. So what is the function you mean?
So mu of S is if S sum of N, they come together, they decide to work collaboratively. They consider themselves as a one player. So it becomes now N minus S versus S game. So remaining N minus S, they are individually working. S, they are working in together. What is best together, they will try to do and how much they are able to generate utility for themselves. That is mu of S. So in cooperative game theory, Shapley value is one of the most prominent solution concept. Even the Lloyd Shapley is the same as the Gale Shapley algorithm. So he even received Nobel Prize of Economics, Memorial Prize of Economics in 2020, I guess, or 12, I forgot. One of these 2 years he got a Nobel Prize. There are many interesting properties like efficiency, symmetry, linearity, null player, and all those things. And it is found to be very useful and getting a lot of fair distribution of this, what agents are able to generate together, how it should be distributed among these agents.
Can you just go back to the previous slide?
So what is that phi function? There is a phi in the next.
And it's called Shapley value.
The nu is a function from subsets of n to
Real numbers.
real numbers. Okay, fair enough. And the Shapley value is going to be something that satisfies the properties which you listed on the next page. Okay.
So Shapley value is like given mu as the input, it will assign some real number to all the agents so that sum of all the values should be what they can generate together. And then symmetric and linearity, if you have two different functions, and multiplier, if somebody is not adding any value, then the Shapley value should be 0. There are some reasonable.
Does it have an argument or not?
So mu will depend upon psi will depend upon mu.
No, but what is the new in brackets?
For each player.
So I think for every,
Psi I is for player I.
Yeah, I get it, but in brackets you have a new.
Mu will depend upon mu, that the characteristic of function.
But also in the first line you should have a new, right?
Yeah, it should be mu here also. I have mu should be mu of that.
But the characteristic function is determined by the game.
Yeah. So we have to define here. In this case, we are defining, and then, but
So
here there is closed form solution for this. To do just next slide. I will show what sides will look like.
I see, but for every game it will be a fixed value.
Yes,
Okay.
it's uniquely determined, and this is the. Shapley also proved that this is the unique function, which next slide I will show, which satisfies these all 4 properties. You cannot have any other function which satisfies all these 4 properties. That was proved by Shapley. It's okay, shall we? So the original definition is this. Consider all possible subsets except I for psi calculation. And how much in that subset, how much is my additional marginal contribution? If I am I, this is my marginal contribution to S. And you weight it appropriately. So that is the Shapley value for player I. And you can rewrite, one can rewrite, it is going to prove that pi be all possible permutations, pi be all possible permutations on N. Then pi is the set of agents who appear before agent I in that permutation. So this is another equivalent definition of Shapley value. So now coming to our game, they are builders, the proposer, its OFPs. So for each of these OFPs, I will have certain valuation, O11, O1N, like that. And for these are like with OFPs, and there are arbitrage which are based on publicly available transactions. These are OFPs have transactions which are not yet made public, so these are called private transactions. So each builder will have another avenue which we call arbitrage. It's AI. So he will participate in different auctions, different OFPs, and he will gather certain order flows. So if he gets that, this is indicator variable, whether he gets this transaction from this OFP or no. And this may be his payment based on the auction rule. So his now net value for holding this block will be AI plus how much he could gather from this. And he will be bidding this amount here. Is the model clear? Means I have to define mu here.
It's not clear. What is PI again?
Payment. I have to make payment. If I win the auction here, I have to make a payment.
Okay.
So the MOF, so for each of them, and if I get the win the auction, if I don't win, then this term will be 0.
Okay. And this guy thing is the winning thing?
Yeah, this is indicator variable.
Okay. But does he know that before the game begins? That
So first you bid here,
okay.
you whatever based on winning and your arbitrage, you bid here. So practically what will happen if suppose you win some of this, but you don't win here. Generally you will make losses in that round. You may eventually make profit because these transactions are still with you. But in this round, you will make losses because you already paid on these guys, but you are not writing the block.
Is
We are
middlemen bidding for contracts and then subcontractor, is that right? So parallel to this,
these are like middlemen.
so you're essentially buying government contracts and then figuring out subcontractors to give the money out, like give the contract out. And in the middle you make the money.
Yeah. So you are trying to make money, but in real life, they are making more money. Here, they are not making more money. Here, your middleman job is to really rearrange in such a way that you can make more money. And that money is actually paid to lot of
Screen share so that's not.
Something which seems like connecting or something.
So now we define our game. So players are proposer, builders, and OFPs. And let OIJ be the valuation for builder BI for transactions in OJ. And AI is the arbitrage valuation which he can make out of the publicly available transactions.
AI also depend on which transactions you end up getting. Like if I want to get these two transactions, buy these two transactions, and build them. If I want to buy these two transactions and by ordering them properly, I can make a profit. But if I build and I only get one of them, then that's not useful. Then my arbitrage value will go down.
Arbitrage is separate. You already know these two transactions. You know how to reorder them. And this is where if you build, you want to get these two transactions, so you are bidding.
Yes, but you may not win both of them.
No, so you don't typically you are not expected to assuming you will win both of them. So generally, this OFPs, if it's with the same OFP, you will not sell individual transactions typically.
No, but it could be across different.
What?
It could be that you are buying two transactions from different OFPs and you are ordering them.
That could be additional complexity can be added here that we haven't modeled yet. You are right. So different OFP set of transactions, what he's saying, can be generated. But you, while generally bidding, yours should be like if you win this, how much you will do this.
So here you're saying that okay, the OFPs themselves are selling you bundles and you are just buying those.
Yeah. So now, when we go to cooperative capital, if the proposal is not part of you, alone subset cannot generate anything. Because proposal is one who is going to rent the block. And we are assuming that OFPs will not try to reorder. But there is already the entity called builder designated for this. So if builder is not part of subset, then the net valuation is 0. Proposal is not part of subset, valuation is 0. And any coalition cannot generate more than the highest valued builder.
So what's an example of set S?
S is
Some subset of
M.
P's and some subset of BI's.
P's alone. These are this could be multiple. So any subset of N is S for
So some
Shapley.
of the left ones, some of the right ones put together is one subset. And if any of them is empty, then its valuation is 0.
Yeah, if empty set is 0. And even if P is not part of the subset, valuation is 0. If builder is if no builder is part of S.
This was empty. Even one of them is missing, the valuation is 0.
Wait, what do you know?
Like your subset only had left guys, not none of the right guys. Then the valuation is 0 and similarly the opposite. So you have to have at least one from this side, one select buyer and seller. Is middle is that
No, this side is only one guy. So this has to be there, and at least one of these has to be there. So if empty set, they cannot generate anything. If P is not part of coalition, they cannot generate anything. If builder is not part of coalition, they cannot generate anything. And if some builder, some builders and some OFPs are there. Then how much they can generate is how much one of the builder will be having maximum arbitrage. So we can get each transaction, and for each OFP, how much is the maximum possible order flow valuation. We'll add that, and for those OFPs which are not part of coalition, then they have to participate in auction. So whether they will be in or no based on that, how much they can add value to the system. So this is how we define MEV. And just some illustration example. So this simple. So there's only one OFP and two builders. So then say builder one has order flow valuation 7 and arbitrage 6, and builder 2 has 10 and 5. So auction setting, what will happen is B1, B2 will win here and will pay 7. The typically second price auction, the game theory assumes second price auction, that is truthful. So he will bid 10, he will bid 7, and he will then win and he will pay 7. So OFP utility will be 7. Now in PBS he will bid because he has now net valuation remaining is 3 because he already paid 7. 3 plus 5, 8. And this guy will bid 6 because he doesn't have these transactions. So his net valuation is only 6. So again B2 will win with proposal. So he will pay 6. So his net utility is 2. Builder 1's utility is 0. And the proposer's utility will be 6. This is what is happening. But if you really compute Shapley value, now actual net MEV will be generated will be 10 from here and 6 from here. You can take his arbitrage transactions and his order flow, and you can make 16. And we can calculate all the characteristic function defined from previous slide. And if you calculate Shapley values, then proposer gets 8.83, builder 1 gets 2.5, builder 2 gets 3.5, and OFP gets 1.16. So in existing setup, OFPs for just having access to the transactions because they are wallet service provider, they are making more money for doing nothing. Proposals are mandatory, but still they are making 6, but their Shapley value is more important because if proposal is not there, this MEV cannot be generated.
So I'm assuming that there are lots of builders and this OFPs, right?
And,
So, typically, how many builders?
typically active, there are 5 builders right now.
Okay.
And OFPs, there are 30 plus.
I see. So that means you can still compute this using this formula. I mean, just computational efficiency, compute the shape of it.
The previous slide, no. We showed that you can compute it for the way we have defined the
Yeah,
gap.
but if the numbers are small, then.
No, but if 30 is not, because there are 2 power 30 combinations.
Yeah,
This has to happen in each block. Practically, like you have to write and sign and all those things has to happen in 4 seconds.
I see.
So, but the way we have written this closed form solution, it happens in 2 milliseconds on laptop. So that is fairly for up to 50 builders and and 5 builders and 50 OFPs. It happens in less than 2 seconds, and for 100 OFPs and 10 builders, it happens in roughly 11 to 12 milliseconds. So what we showed that for OFP, Shapley value is directly closed form solution, and which can be computed in OFN.
So what's the special structure?
What?
So what's the special structure then, which you're exploiting?
Yeah, so what we are doing is like we are, so if you remember the second definition, it has a pi I tag, like set all the agents appearing in permutation before agent I. So all the agents before OJ star, so if you are calculating for OJ star, So we use this definition. And then we actually intelligently split this permutation into partition into different sets. And for each set, this value is same, it's not changing. That partition of permutations, this value is not changing, and then we calculate frequency of each partition, like how many entries are there in each partition. And then we could get a closed form solution, which was shown on previous slide. So all the proof details are in the paper, which is available on archive. And similarly for proposer and builders, we have closed form solution. So the key idea is like partitioning this permutation in such a way that in each partition, this value is not changing, and we could compute the number of entries in that partition. So we could get direct closed form solution for this.
No, my question was that is not possible in general, I'm assuming.
General Shapley value game is explanation.
Right. So then what was the precise structure of the problem which
Because addition of some builder can, if he is a maximum arbitrage value, then only he will change. So addition of some player will make him second highest. That time his marginal contribution to that subset will change. Till that point you add or delete in between, you know. So we just keep counting those. So when your marginal contribution to that ordering is going to change, we could calculate that. Because the structure to this characteristic form game, right? It's max of all the arbitrage values plus max of all your OFPs. So even for proposal, we got a closed form solution, and for builders also we got a closed form solution. So for builder, we had to get sum of 3 different terms. The one term required a little bit more computation, so it becomes order n into n log n. So any questions here till now?
But the approximation is like if you find do the costly computation, can do cheap computation and come close to this.
For this game, you don't need because it's already. But in general, yes, there are a couple of papers which do. Even our next part, we could not do it, such partitioning. And then you just do sampling theory, use the result from sampling theory of Ding's inequality, and based on the situation, you can bound. So some cases, people have found that even constant number of samples are sufficient to approximate Shapley value by 1 minus 1 by e. For the next game, which will be defined, you can get arbitrarily close to Shapley value. The number of samples required will grow accordingly. And just to be also data, like how does it change the structure? So if you would have been doing traditional auction setup, the utility for proposals, we assume there are 4 builders, 1 OFP. The utility for proposer actually increases because of Shapley value. Builders also increases. And the OFPs, their utility drastically decreases in our setup as compared to existing setup. Which we believe it's fair enough because these OFPs are how to actually eventually allow the transaction. They cannot keep on holding transaction, waiting to find out the right person and selling it to them. Because they are wallet service providers. So if other entities decide to go cooperative game theory approach, then they will not make anything because then they will not share anything with them, and eventually they will make the transaction public and that will get captured in arbitrage. So arbitrage value will increase and order flow valuation will decrease. So anyway, they will not make anything. So it's better for them also eventually to join such a cooperative game. And one interesting thing also we observed that net MEV generated also improves because we have now nullified the competition. Like for certain OFPs, you are able to extract more value than me, but I have more arbitrage value. So transaction from that OFP which you have ordered and my arbitrage value, those two could be combined. Right now, you are working independently, I am working independently. So our observation says that we could almost get 30% improvement in MEV generated. But this is all based on simulated data because we cannot deploy it unless Ethereum is willing to deploy our solution. So we studied like valuation generated with different distributions. In all distributions, these patterns were similar. And we also studied like if number of builders keep improving, how different entities utility change as compared to auction versus MEV game, which we have introduced. So significantly, OFPs will get reduction. The builders also see reduction as number of builders increases, but OFPs will be really suffering more. But we believe that should be fine. So I will move on to next part if there are no questions here. So as I stated in the beginning, like these all MEV generated because of transaction creators. But what is for them? So there were some blogs written on Ethereum websites that we should provide them some incentives. And this order flow transactions, especially through OFPs are coming, their MEV generated through this is increasing. Now almost 30% of MEV transactions are coming because of private order flow coming from OFPs, and they are constituting almost 60% of MEV. But nothing for transaction creators. So what these blogs on Ethereum have written is they are saying that there should be, they call it matchmaking instead of OFP. So we'll also call matchmaker. So instead of builders, because the terminology with the blocks, they focus more on searcher. So we use searcher here. So searchers are submitting bids to matchmaker, that is OFPs. This is a single OFP, not multiple OFPs, no. And he has different transactions. So they said, okay, if I get this bundle of transactions, I am willing to pay this much. This is I am getting this bundle of transactions, I am willing to pay this much. As an auction happens, and OFPs are making a lot of money. The idea in matchmaking is they should not be making money out of this. So whatever money they are generating from this auction, let's go back to the transaction creators. So that transaction creators are also happy. They will remain with you. They will not change the wallet service provider. Sort of like loyalty bonus in our banking.
And you use the same Shapley Value setup.
Yes. But now game becomes very challenging. It doesn't turn out to be as easy. Like we could not partitioning the different permutations. The way we did in previous game, we got only fixed number of different after partitioning. Each partition has the same marginal contribution. But here we show that number of marginal contributions are already sub-exponential in the end. So you have to add them, you will need sub-exponential time.
So Shapley Value is just one solution concept, right? So are there other
There are few more. Bunzhop index is another solution concept. But that is not as popular as Shapley Value because Shapley Value has the most fair way. So Bunzhop index was before Shapley Value. Still some economists in some context use Bunzhop index. Then there are other concepts called core. Core is supposed to be having stability, like it has relationship with your matching theory. You also would have studied core and stability. So the allocations, how you should distribute. If that allocation is in core, then but core could be empty. Shapley value is always there. Core need not be unique. So there will be many other challenges. So incorporating
approximate core or something like that.
Yeah, one can look at all these concepts, but for here because you need one unique solution. So Shapley value makes most right choice here. And I don't think in core you can compute in polynomial time in general.
It's a bunch of inequalities, right?
Yeah.
Inequalities will be satisfied as a quantity.
So matchmaker is OFP. And so these profits, we want to give it back to the transaction creators so that the transaction creators remain faithful with you. I will just come to the definition of. So there are certain challenges because this is more communitarian in nature. So we want to find out there are no two different sides. One is searchers. They are paying to the these things, and but we want to give it back to the transaction creators. So in economics, there are concepts called redistribution mechanisms. Those concepts are not useful here because transaction creators are not bidding in the system. They are the searchers who are bidding. And so how do you find out inherent value for transaction creator for his transaction? So again, we want to use Shapley value. So what we do is, say T set of all transactions available with the matchmaker. These are the searchers interested in these transactions. So searchers valuation function may be complete commentary in nature, but we will restrict to only single-minded bidders. That means we're interested only single bid, single bidder. And the PSI with the payment from searcher. So what you want to distribute is this remote note of revenue which you will make out of this auction. How do you distribute this off? That is the question we want to address. So what do we say that? If T is a subset of all transactions, so we want to find out mu of T, that characteristic function. So let ST be the searcher who are interested in this set of transactions. This bundle is subset of this T. Otherwise, there is no more. So I'm interested in transaction 1, 3, and 5. If I'm getting only 1 and 3, as she was saying, then I may not be interested. So my valuation for strict subset of my interested bundle is 0. So if I'm getting a superset, I can just add them in the bundle. My valuation is not going to increase, but I can add them. So if T is superset of my interested bundle, then I am part of this HT, and then the auction will make sense only for searchers in HT. So let's calculate how much revenue is generated from this set of transactions. And this we will call it this transactions. So this T are able to generate this much valuation in the system now for the matchmaker. So we'll assign mu of T to be R of T. So this is how we define RST game. But before coming to R of T, this single market option is a bit challenging. Because I'm not interested in any strict subset of my interested bundle. So we can, it has been well known that you can reduce it to independent set problem and is NP-hard. But the best well known for auction setting algorithm is true time approximation to the social welfare. I'm not getting into details of this algorithm. This is like coming from auction theory. You sort the bids based on your valuation for that bundle divided by square root of the cardinality, and just greedily start allocating the bundle as long as you can do it. And then payment is the next bundle which intersects with your bundle based on that bundle's bid, you will collect the payment. Because how you are going to get revenue, it's coming from this option. So this game characteristic function will also depend upon this option. If tomorrow this option is changed, then our results may not hold true. Our results which are sitting as with respect to if you are getting revenue according to this option. And an interesting fact about this ICSEM is not monotone. If you drop some transaction, sometimes your revenue may also increase. That can happen here. So this is an example where if you drop T1, actually then revenue is increasing. Because this is, if you have done exact computation, then this will not happen. But we are doing approximation. And because of which this can happen, approximation becomes better by dropping some transaction. So your revenue increases. This is another challenge we faced in this. But so what we decided that we will then compute Shapley value for all the agents and normalize its Shapley value with the sum of all the Shapley values, and that fraction will distribute him back. That is what solution we proposed. And the valuation, if I'm okay with some subset of BSI and my valuations are additive, then we can compute Shapley value again in O of N, and we can partition and all those things also can work. Or another interesting result from previously known result, that Shapley value for additive valuation, additive characteristic game, it's polynomial in N. So either we can reduce that if valuation for searchers are additive, we can reduce it that corresponding Shapley game, the characteristic form game is also additive. That also we can do. Or we can do independent of reducing this, directly part of the previous approach, partitioning the permutation sets, we get it O of N. But in general, if it's single-minded bidder, that I'm interested in that bundle, not any subset of it.
Maybe try to wrap up.
Yeah, I will just tell this result. So this we call marginal contribution set. And we show that this is at least 2 power root n. So even if we partition the permutation sets, the number of entries which we have to add up are exponential, some exponential in n. So we cannot expect it to be in polynomial time at this point. I wanted to get into detail, but this will take a long time. So I will not get into detail of the proof, but the proof is like we consider 2 root n searches and n is greater than 16. So there are n transactions. So T1 to T root n, then we just split them in root n cross root n set of transactions. So first searcher is interested in this row, second searcher is interested in this row, like that. And next root n searchers are interested like this root n transactions. Then this is wrapped up here like that, one shifted. And then we could argue that. So we split like those who are interested in row weights, they're like this, and these are like diagonal weights, B0 and B1. The root n searches here, root n searches here. And we are assume that their valuations are like this highest valuation, this is lower than this is lower than this, like they're decreasing order. And in particular, they are like, so this is 1 and this is 3 square like that, up to 3 power root n minus 1. Then we could argue that any transaction added to some subset, at least we showed that two root n subsets, the transaction shifted here and there, some ordering, its revenue is going to change. It's going to be completely different than not appear in previous computations. So, and there are 2 power root n such combination at least where is marginal contribution is changing. So you have to add those many, and hence we believe it should be sub-exponential. Again, it's believed because it does not mean that Shapley value computation itself is sub-exponential, because the way our approach is sub-exponential, but maybe there is another algorithm which somehow predict this pattern, which in those pattern is there are sub-exponential number of different marginal contributions. You somehow have some pattern into it and which can directly compute its sum. If there is some black box algorithm is there, we don't know. But we strongly believe it will not happen. So we just then, as Rahul was asking, can we do approximation? And for this game, yes, we could do approximation with just of n different samples. This is our algorithm. How we do calculate Shapley value approximately here. And this algorithm needs this many samples, k number of samples to get T error in the Shapley value with probability 1 minus delta. And we did some simulations about this algorithm on smaller number of transactions, which shows that this algorithm gets very good approximation to actual Shapley value. They're very close by. So in future, we want to explore, are there beyond single-minded bidders, or can we get even single-minded bidder if your valuations are bounded? Right now, our valuations were like very sparse. So they become of the order 3 power root n. maximum valuation was 3 power 410. So if someone is fixed, is bounded, can we get polynomial time algorithm for Shapley value? And any other economic concepts can be used for better welfare of all the parties involved in the system. There are some important references.
Questions?
So how do you get this adopted? And that is the biggest challenge.
Yeah, so there was the most the Flashbot is one of the most prominent builders. So we wrote to them that we are interested in contributing the proposal and all those things. But then they in the past they used to give researchers some money to do research and like propose them and some of their solution adopt in the system. But then all of a sudden they stopped paying and looking at this. But otherwise we had to propose to them. But I don't know more than that. Unless we know somebody, influential people in Ethereum, it might not be easy to get adopted. By the way, second work will be presenting in Amas. My friend will be presenting because I'm not traveling. It is in US. The first work is still under review. Thank you for giving me an opportunity.
Thank you for coming.